Good morning and welcome to the DevFest Berlin 2025. And let's begin with the first session, Tiny LLMs on the Edge. Um, Before talking why we need, first of all, tiny LLMs, like we know LLMs are working greatly. But when you talk about the tiny LLMs, there are some pros, there are always some cons, but let's talk about what the pros and why we need in the first place the use of tiny large language model. So as you know, the LLMs are the large language models, and it takes a lot of memory when you are using it on local, or even you are consuming the API in forms of always when it comes to the deployment, it takes the huge memory, plus there are some connectivity dependency that you always need to connect it to the internet. There are data privacy concerns because you are sending the data to the APIs, to the models, and plus the high operational cost. But when it comes to you have to use any large language models on your edge devices or even any tiny small devices like the Raspberry Pi, doesn't matter whatever it is. You can do it with the use of tiny LLMs because first of all, we have the enhanced privacy because we are not sending any confidential data first to the cloud platform. Whatever data is remains on your devices. So that's the huge benefit, I would say. Then the real response time, because you're getting response within a quick minute. You can use it offline because it's going to be there on your the mobile device. It's not going to process at the cloud end or any other, for that matter, the server's processing is getting. Offline functionality, you can use it anywhere, anytime. These are some sort of the pros that we are dealing with when you have like the tiny LLMs. So how it actually working? Because when you talk about the LLMs, we are using the thousands of data which is scraped from all over the internet, and the parameters we are getting is huge, and so the model size is completely huge, like billions of trillions of parameters. So how we are making it work it on mobile devices? First, the method that works is the quantization. We are kind of reducing the model size marginally, because if you are running on your on your phone, we can't use the 40 GB large language model. We need to some compression. So that's how the quantization works here. We are doing the weight compression because the model we are running, it's we are converting the floating point integer to the integer like int 8 or the floating point precision 32 to the integer bit. So the model size has been marginally reduced to the 1 GB, maximum 1.2 GB, which is right now the Google is using in their phones. Apart from that, there are some architectural tricks behind converting into large language model to the tiny LLM. These are sort of like architectural in terms of model building or the model training, how you are training your the large language model, how we are converting your large language model into the tiny LLM. So first is a group query attention. So behind the LLM, you see there are the transformer architecture which goes behind, and we are here kind of grouping the queries into the one single group based merge, and then we are putting it to the user end. So that here we are reducing the time again in a shared feed forward layer. These are all the architectural changes that we do behind the scenes. Third is it's a knowledge destination. Like suppose we have like a ChatGPT 3 with the Flash has not coming, and we kind of now want to transfer this huge knowledge into some small brain. It's like you have two brains right now. The one is a bigger one is smaller one, but you're not using right now the bigger ones, and I want to go for like a smaller brains right now because that's how I want to make it work on the smaller devices. So here in that terms, we are training the model on a huge data, but we are not sort of consuming all the knowledge we are getting from the large language model. We are just keeping some of the information from the large to the smaller ones. Here, when you talk about the knowledge destination, of course, you're losing some sort of accuracy. But in terms of a speed, you're getting at this point, it's tremendous. So it's a kind of a trade-off between the accuracy that you're getting and the speed that you're working on. There are some the hardware relatives when you're talking about the on-device. It's like 1 3B parameter models requires around 6.6 to 1.2 GB, or sometimes it goes beyond that. So if you're right now, okay, we have the 64 GB, 128 GB RAM phone, but at the same time, if you're consuming that amount of memory, the energy comparison or the cost comparison goes beyond, it's a tremendous. So of course inference speed is the quite higher in this way. It's a 2040 tokens per second, because we are not training model right now, we are just inferencing like already trained brain, and you are just asking them what to do. So this is the inferences thing, like you need to get the output in a few quick seconds and you don't want to wait for it. So that's how it works overall, like when you go about the optimization technologies like a quantization or the knowledge destination overall. Here comes the Google AI Core and Android on-device ML APIs, because we have the Google Android device is completely different, and the Mac and iOS support is completely different. So when it comes to Google's, it's a system in system service. So Google has introduced AI Core. It's in terms of, we can call it API or some sort of service which runs in the hardware platform. It's already inbuilt in your the chip or in your device, which kind of supports your all the machine learning based tasks or AI based tasks. So suppose, for example, you want to take a selfie and you are getting the tag at the same time. How is that working? The face recognition. These things are running on device right now. You're not processing, you're not sending your data to the cloud server, and then you're waiting for the response to come. Of course, these already been implemented so far before, but the speed at which we are working at now, because of this, is the quite at a good speed, I would say. Also, there are some perks of using it. It's like network independence, data isolation that we already been talking. We are not sending data to some cloud server platform or any sort of service right now. We are just whatever images you are capturing, it's all remaining on your devices. So the responses are quicker. You are getting you don't have to download any some sort of model on device. It's API which is all doing the sort of work. Or in terms of the chip, they have already been introducing, and they are introducing the new things which will enable to feed forward this task, I would say. So this is a core example, I would say. In the bottom, I would say if you have to initialize in the development, you have to just call this API and you have to create a context. So context is like you're telling the model what sort of input I want to give. Suppose you are building a chatbot and you are deploying it on an Android device. You need to provide a context, what sort of output it should generate or what sort of response it should give. So that sort of context generation, you can just, this is a kind of bit small snippet of the code, but it's API calling which made the simple to the user or the developer, I would say. Also, when you talk about the TensorFlow Lite, so there are some frameworks when you're developing large language model or overall deep learning. Like a TensorFlow, the PyTorch is coming and people are using it insane. But the TensorFlow, it has a great community support, so it's easier to integrate with in the first place. So these are some, I would say, code example, code snippets, how you can do it in a Kotlin. You just need to, as I say, create a context and pass the text what you want to. If you want to say like a generate a text or generate any image, you can just pass it to. This is kind of bit really short example, but you just need to pass the model API, model in API endpoint, and the model which you want to use. Right now, the TinyLLM TF Lite is just one model, but there are other models are right now in the use, like a Gemini, ChatGPT, whatever you want to call it, you can directly call it from here, and it's a couple of minutes of a task. You don't actually need to be as a hardcore developer, because it's at the end of the day API calling task and kind of pretty make easier because of the Google's engine. On the Apple side, Apple has introduced, there are two frameworks, the MLX framework and the Core ML. If you talk about the Android doesn't allow you to perform training on device. You are just doing the inferencing. Whatever you want to generate an input or output, you are just, the model is just there. You are not performing actual model training. But when it comes to the Apple has sort of made it bit to the next step, and it introduced the MLX framework. You can do full model LLM training, which is quite insane, because if you're talking about on the mobile devices, you get like a power and energy consumption is too high in that case. But with the silicon chip that they have introduced, they are kind of able to surpass this thing. Also, they are providing the quantization support. So the model you're using, it's not that big. At the same time, there is a GPU acceleration with a metal performance shader. So it's a kind of chip building technique that you're introducing, because you don't want to at the same time heat up your device too much. You don't want to my energy to be consumption at a really high level, because if you see on the Google side, the Google phones that you're using, maybe after Google 8, 8 Pro or 9, the battery consumption has been lowered, but before that it was quite insane. Like the battery used to drain in 2 or 3 hours. That too, you're running the normal application. If you're going to use the AI application, so I don't know what's going to happen, because it's getting really heated pretty fast. But with Apple's MLX, it's kind of trying to make some sort of improvement in not just time of a chip, but also how the model is working. On the other hand, Core ML, it's an inferencing framework that I have interest, not for the training the model on the device. So it's 3 or 5 times faster startup when you start any application, or you're embedding some model behind in your application. There is a smooth token generation. You can use it offline, and that's a pretty much good to say. And these are the some of the good facts about, I would say, when you're using some AI devices or AI application in your Apple devices. If you have to introduce like a MLX framework, how you can do, or you have to just go for the inferencing, these are some the snippets. If here the first step that you need to do is, you can't just use model as it is. You need to perform a conversion that the Apple's hardware should accept. So if you have some model, even the pre-trained model, and you want to use it to generate the new model, you need to first convert it to .ml model extension. If there are some, even if if you are developing some applications, or we are deploying some models on a cloud platform, there are the frameworks, or there are the extensions that work like a H5, HDS, different model extensions are there. So one which accepted by the Apple is like .ml model. So need to first the conversion of the model, then you need to quantize, because it's a really huge model. You can't really directly use it as it is. So quantization then works. It tries to reduce the weight, and it tries to make it as smaller as possible. And then you can do the inferencing, because at the end point you can just plug in your APIs if you want to directly consume it. This is one of the example where you're just saying model.prediction, and you're saying input explain on device AI what it is. Really small example, but just give you and just how you can integrate with, how you can call the API of the TinyLLM. About the MLX framework, so it's again an open source library, and we can use it for training, inferencing, and it comes with a metal acceleration and mixed precision. So a mixed precision is like, okay, there are floating point 32-bit and integer 8-bit, 4-bit. And I don't want to, if you're converting the floating point 32-bit to the integer 8-bit, you're losing some sort of accuracy, because in the end, when you talk about the model training and model parameters, all about the maths or the mathematicals. There's always a matrix calculation that goes behind. So as big are the numbers, as the accuracy is going to be good. So to do that, people go for the quantization, but it's about mixed quantization. Is you're using the integer 32-bit for some smaller tasks, but I need a great accuracy at the same time. I don't want to lose it on accuracy. I'll be keep it to maybe the floating point 32 for that matter. I can reduce it to the floating point 16. But more the floating point has in the models, the greater is the accuracy kinda. But here they are kinda allowing to do both the formats in your model. So this is AutoML for casual LLM. It's from a pre-trained model. You can call it the TinyLLama, or if there are any other like ChatGPT, Gemini Pro. You can call any API here, and you can just generate a token, and it will create a tokens for your model, and you can pass it to the decoder, so it will finally generate an output. So at the same time, it is doing both the tasks of generating and training the model, and maybe you can also integrate the API endpoints here. Let's talk about the cross-platform development here. So if you're talking about the native API, if you want to consume on the Android and iOS, go for, I would say, AI Core or a Gemini Nano. Because right now, if you are using the Google's phone, any Google 8 Pro or more than that, they have introduced the Gemini Nano in their the devices. So it's a kind of useful thing. You can just plug in if you want to, if you can just remove that feature if you don't want to in your application. With the iOS also, there is a MLX and Core ML. You can switch it as you want to do some perform on device model training. Custom model, TensorFlow Lite it's also one framework that you can use it for. On the other hand, the iOS, it's a Core ML. PyTorch is coming also with the iOS, which is a good thing. Framework side, TFL Lite, MLKit, MediaPipe. MediaPipe is kind of useful when you're doing some motion segmentation, image detection, object detection, like a kind of you're taking a selfie. I would say, just give an example. It's about kind of face detection, it's object detection behind the task. So yeah, these are some of the frameworks, the languages. Of course, with Android, you can use the Kotlin, Java. With iOS, the Swift. In terms of the inferencing, it's a CPU, but on the iOS side, it's a neural engine which works. Android gives you this power of using the CPU/NPU, that is neural engine, but with iOS, it's a standby neural engine that you need to work. There's no kind of as such CPU because you are doing the training, which normal CPU can't handle it that easily. So these are some the frameworks, APIs that you should consider while developing the application for the Androids or for the iOS. Once you are developing, what sort of model conversions and what optimization workflow you should consider if you want to build a pipeline. ONNX is the model, I would say, it's a version where you want to convert your PyTorch or the TensorFlow model, because usually the developers prefer to build model in these, because TensorFlow and PyTorch has a great community support. They started with the model building. So that's why we need to convert this in ONNX Runtime platform. Right now, this is the Python example because we are right now building on the Python application. But of course, you can do it in a Kotlin or any other Android development language. On the TensorFlow Lite converter, once you're just doing it, you can optimize that model and you can make it work into the Core ML or the Apple API. So this is where the converter.convert is the method, which is a method which is used to convert your any pb.pb or the keras file, because when you are training a model, you are building a new model, it generates the model in specific format like .h5, .pb, .keras. These are the model extensions. But when you have to use it on the Android application, you can directly use that. You need to make it convert into proper mobile side applications workable, like for Apple is .ml model. So that's how all the pipeline goes. Do it for the quantization. You can quantize here also. At what level you want to perform the quantization is also a task. So these are some examples, and let's just talk about the real life application. We can use it in a voice assistant, text summarization, like we are using on in the Google. We are asking Gemini or any other model what sort of instructions it has to summarize. So it's on device. It's easy to manage, easy to integrate. Yeah, and if you talk about the current challenge and solutions, it's like, we'll see are working on the memory management, because it's a big task when you're consuming the model. It's a kind of also the accuracy trade-off, because large language model has a great capability, but when it's about to deploying on the machine or the model, it becomes a tremendous or difficult task to do the same. So these are the privacy concerns, security concerns, and the challenges we are still facing. So there is a whole lot of work. I mean, I was trying to get complete, but yeah, if you have any questions, you can talk to me later after the session. You can ask anything. It would be great to talk about. Also, so if you have any doubts, you can call me later, but yeah, you can give the feedback over here. And thank you so much for listening.